Hi, let's continue our discussion of non-idealities of op-amp. As we have been talking about op-amps, till now we have not talked really about changing signals as an input to the op-amp, right? So if you have an op-amp here, we have always assumed that the input to the op-amp is going to be kind of a fixed signal, or we have basically ignored time. So let's put an input which changes with time, okay? And let's write the differential input to the op amp specifically as a function of time. Now the question is, what happens to the output? If the input changes very fast, does the gain of the output remain the same? So for a a slowly changing signal, and for a fast changing signal, does the uh, gain change, or does it remain the same? Those are the kinds of questions that we want to ask. Okay. Now, I'm hoping that you know that for a slow changing signal and with a fast changing signal, the parameter that tells you how fast a signal changes is called the frequency, right? So what we are asking is the gain somehow dependent on the frequency of the input that we are given? And the answer is yes, it is. Okay, yes, it is. And one way to talk about this characteristic is to say that if the frequency of your input becomes very high, then you don't have as much of a gain, or the gain starts to reduce. Okay, and this parameter is measured by what is called the gain bandwidth product. So gain bandwidth product, as the name suggests, is the product of the gain of the amplifier and the bandwidth of the amplifier. I'll just talk about what bandwidth means. Okay, bandwidth is basically the range of frequencies that the op amp can amplify or pass through easily. And in many op amps, the gain bandwidth product is a constant. Okay, it's a constant C, okay, which means that if you use a higher gain, the bandwidth that you can use the op amp for reduces. That is, the frequency that you can use the op amp for reduces. So let me draw a graph, and hopefully this will start to make a little bit more sense. Okay, so on the x-axis I draw f, and on the y-axis, let's say we have gain. Okay, and the gain bandwidth product of op amp basically suggests that we have a relationship something like this between these two. What does that mean? Now think about this. If you use your amplifier at this gain, okay, so this is the gain that you want. So this gain can be given by the amplifier till this frequency. Let's call it F1. But if you want to use the op amp with this particular gain, let's call it G2, which is much higher than G1, then you can only use the op amp till this particular frequency, F2. You cannot go till F1 because the op amp does not allow you to go for a higher gain at that particular frequency. Okay, and you could say that the product G2 times F2 is the same as G1 times F1, though in real op amps that may not be true, but in many cases I think that is a good rule of thumb to think about this phenomenon. Okay, so let me kind of summarize this. So what I'm saying is, in an op amp, if you want a higher gain uh, uh, in your amplifier, in your op amp, then you will have to limit the highest frequency signal that you can amplify using that gain. Okay, and if you go in for a lower gain, then you can increase your bandwidth. You can increase the frequency of the signals that can be amplified by that op amp, or by that amplifier. And that is encapsulated by this idea of the gain bandwidth